Okay, so up at the top, that's just a review of what we just went over. We used to do this on different days, so we won't go back through that. That's just using the distributive property. So first we're going to fill in these blanks. Terms and coefficients. The parts of an expression that are added together are called terms. The number part of a term, like if we were to look down here, 2x is a term. The number part of that in front of the x, the 2, is what's called the coefficient. So when you hear someone say the coefficient, think the number in front of the variable. That's what a coefficient is. Okay, so in this case of this example, we have 2 coefficients. We have a 2, and this is a -1. Remember, if there's no number written in front of a variable, it means there's a 1 there. So -1 would also be a coefficient. So coefficients are -1 and 2 there. Okay, next point down there, first word you're filling in is the word constant. A constant has a number part, but no variable. In other words, all the numbers you're used to seeing your whole life. When you just see a regular old number, that's a constant. So in this example, a constant would be 8. And then that last blank we're filling in there is the words like terms. So like terms are terms that have the same variable part, such as -x and 2x. The variable part of both of those is x to the first power. Okay, when we have like terms, we can combine those together. Also, constants are like terms. You've combined constants ever since you started doing addition, way back in elementary school. When you did 1 plus 2, you were adding constants together. You were combining those like terms. Okay, so move down here, and we're going to identify the different parts of this. So when we have 3x minus 4 minus 6x plus 2, first we're going to write down all the terms. Okay, terms are separated by plus or minus signs. So this would be a term, that would be a term, that would be a term, that would be a term. So our terms here would be 3x. I'm just going to separate them by a comma on this line. The sign in front of this goes with it. So -4 would be a term. -6x. And 2, bless you. So we have 4 terms in that expression. Okay, we have 2 sets of like terms. 3x and -6x are like terms. They both have an x to the first power. So 3x and -6x. And then our other set of like terms is the constants. -4 and 2 are like terms. If we were to list out the coefficients, coefficients are just the numbers in front of variables. So we have 2 coefficients here. The coefficient of this term is 3. The coefficient of this term with this x is -6. And then our 2 constants, once again, just think of regular old numbers, no variables involved, but constants. So we have a constant of -4 and a constant of 2. Okay, so that's how you would identify different parts of an expression. Main thing is not so much being able to separate them and write them out like that, but being able to identify them. If someone said, how many terms are in this? Being able to count up the number of terms. Which ones are like terms? That's what we're going to be combining next. So if we move down to the bottom, we'll do these 2, and we're going to just do some of these on the right together, because there's not many examples before it's this classwork. All right, with A here, start with the first term, and I see a y term, y to the first power. I like to underline it or circle it, just so whatever makes you identify it. And then I'm going to go through, and I'm going to find any other y to the first terms. Here's another one. I'm going to underline that one. So those are like terms. I can combine those. So what would 7y minus 1y be? 6y. Okay, now you don't have to do this, but after I combine them, I cross them off. Because I know I've already combined those, I don't need to look at them anymore. So my other like terms here are 8 plus 13. So what 8 plus 13 give me? What would it be? 21, yeah. So 6y plus 21. So that is combining like terms. Really the only way we make it harder today is we're going to throw in what we did on the front side. If you see parentheses, if you see something that looks like the distributive property, that has to happen first before you can combine anything. So go through and use your distributive property. What would 5 times n be? 5n, and then 5 times 7. 35, yeah. And this one has 2 distributive properties we need to do. So we move on to the next set of parentheses. What's 4 times 3? And then 4 times n. 4n. Once you've done all your distributing, now you can combine like terms. So I start the first term, I see a 5n, and down here there's a 4n. So what is 5n plus 4n? 9n, right. And then all we have left, and I always circle the sign in front of it because it goes with it. I have positive 35, positive 12. So 35 plus 12, 47. Very good. And that's all there really is to it. So let's just look at a couple more and then get you started on the homework with a little bit of time left. Okay, over on the right side, something like number 1. Don't get confused by those parentheses. Tendencies, people see that and think, oh, that means now we're multiplying. Those parentheses really don't even need to be there. That's still just 7x plus 11x. So those are like terms, correct? Combine those and what do you get? 18x. And it's usually the simple stuff that tricks people up. If you look over to the right of that, what is the number in front of that y if there's nothing written there? 1. So that's 6y minus 1y. What would that give you? 5y. Good. And down in the next row, number 2, there's only one set of like terms there. Which 2 terms can we combine there? 5 and 2. So 5 plus 2, you get 7. And there's nothing to combine this 2 in with. So when that happens, you just bring it down. So 7 plus 2n. And the order we write that does not matter. You could put 2n plus 7. Okay, with addition, order doesn't matter. Because 1 plus 2 is the same thing as 2 plus 1. It all works the same way. Okay, move over to the right. 7, we have distributing to do first. So we got to distribute that 2n. So what is 2 times 4a? 8a, and then 2 times 1, 2. Okay, then we're just going to bring this down for the next step. Bring down that plus a. So we got a set of like terms. Which 2 terms can we combine? Yep. 8a plus 1a, which gives you 9a. So we end up with 9a, bring down the plus 2. Let's do 2 more. Let's go down to 3. So distribute that 3 in. What's 3 times 2? 6. 3 times c. And then bring down the minus 1c. So your 2 like terms there, 3c, negative 1c. So 3c minus 1c gives you what? 2c, right? And I just brought down the 6. So 3c minus 1c gave us 2c. Okay, last one we'll look at is 4, right below that. Just because, once you realize, not always are you going to have like terms to combine. This goes back to what we talked with last part on the distributing side. What would 15t times t be? 15t to the second power, right? 15t squared. And then 15t times 4. What's 15 times 4? 60. So 60t. On that one, you are done. There's nothing to combine there. The t squared is not the same as t to the first. Even though they both have a t, it's like a completely different variable. That might as well be a t, and that might as well be an x. So we just leave it right there, and you're done. All right, any questions with any of those? And it's going to give you about 13 minutes to start homework before advisory time starts. The homework, let me show you, pass it out. I made a copying error. I didn't want to waste paper. So this is the only side you need to look at, the side that says combining like terms. Okay, there's not a separate side for the distributed property because the distributed property is built into combining like terms. I accidentally put something on the back there. Same thing you did yesterday. You can just cross that off. Does that make sense? The order of operations set. Started to recopy it and then realized wasting paper was a bad idea.